Assalamualaikum warahmatullahi wabarakatuh. We are from Group 10. Today we will present our project about reduced instruction set architecture. I will start with abstract. Reduced instruction set computer RISC architecture is a type of microprocessor architecture that utilizes a small, highly optimized set of instructions rather than the highly specialized set of instructions. Number two, it is alternative to the complex instruction set computing (CISC) architecture and is often considered the most efficient CPU architecture technology. Number three, improve performance achieved by simplifying instructions that can do less but execute fast with RISC. RISC microprocessor or chip take advantage of the fact that most computer instructions are very basic. It simplifies and expedites data processing by reducing the number of instructions permanently stored in the CPU, relying more on internet instructions. Number five, an important RISC characteristic is that it allows engineers to expand the register set and boost internal parallelism by increasing the number of parallel threads processed by the CPU and the speed at which the CPU executes instructions. And the last one is also significant because it can deliver high performance per watt for battery power system, which results to high efficiency.
Hi, Assalamualaikum. My name is HAFIZ bin RAHMAN and my matric number is 074987. Today I want to introduce about RISC. What is RISC? RISC is a reduced instruction set computing. It is a family of microprocessor designed to perform computing tasks using the simplest instruction in the lowest amount of time possible. So RISC inverse of a CILC is meaning of complex instruction sets computer. It is frequently regarded as the most efficient CPU architecture technology available today. RISC microprocessor or chip take advantage of the fact that most computing instructions are very basic and computers are intended to handle this simple instruction rapidly. So RISC simplify and expanded data processing by reducing the number of instructions permanently stored in the CPU and relying more on external instruction. An important RISC characteristic is that it allows engineers to expand the register set and boost internal parallelism by increasing the number of parallel threads processed by the CPU and the span at which the CPU executes instruction. The design utilizes a set length of instruction and it's easier to pipeline. Operation execution time is minimized, support more register and spend less time loading and saving item in memory since it's like complicated instruction decoding circuitry. So RISC also have high energy efficiency by delivering high performance per watt for battery power system due to uses of an operation per instruction. And RISC easier to pipeline because of minimized operation execution time. So that's all for me. Thank you.
Okay. Now on to structures, design, and architecture. Here we can see the block diagram for Risc architecture. In Risc architecture, data is moved interchangeably between the main memory, data cache, data path, hardwired control unit, and instruction cache. Moving on. The architecture of a reduced instruction set computer processor is operated by the hardwired control unit. this one here. So what it does is it sends control signals to the other parts of Risc architecture, and they in return receive or produce signals of their own from its orders. It's basically the mastermind of Risc architecture. It controls entirely what it does. This architecture focuses heavily on registers instead of memory. Now this is why Risc architecture is so quick, because it does not rely on memory, where if you have to pull it from memory, other architectures in comparison will be very slow. With Risc architectures, it just pulls it from registers nearby, and registers only, especially in Risc architecture, only store few bits of memory, so this process happens really quickly because there's not a lot of data to store, and you don't have to go to the problem of pulling addresses from memory and all that. You just have to take it from registers and execute those instructions or send it elsewhere. Yeah, this is because registers are significantly faster than any other reliable memory source which can be found in the processor. Registers are also practically tiny and ideally designed to be right beside the ALU and control unit. So registers are small, and because they're located right beside the ALU and control unit, the control unit can easily send signals to the register. It's close, so it's fast, because it doesn't have to travel a long distance to, like in the main memory or the hard drive disk, to access that information. It takes too long, so the register is a quick option. And the ALU, which is essentially its processing unit, the instructions are then sent from its register to the ALU, so that'll make it quicker. Instructions of this architecture are not only easy, well, this means it's simple for the computer to comprehend, but also executed only once per cycle. And this is really one important aspect of Risc, reduced instruction set architecture. Because it's only executed once per cycle, it's just that much quicker than, let's say, CISC, complex instruction set architecture, where it can execute several times per cycle because due to the complexity of its nature. Here the instructions are simple and are only executed once. So this gives it that feasibility of being nimble, quick, and simple. Its programs does not take long to execute the instructions because they're easy, and it only happens once per cycle. Therefore, all instructions using this architecture are hardwired, meaning its response to instructions or functions are made permanent using connected circuits. They're all connected, everything is interlinked, so it goes from A to B to C, and it just goes within that small circle. It doesn't go all the way to other components. It's just within these components in the processor, which makes it just that much quicker, just that much faster. Moving on. Risc instructions also have a definite size, and each one handles one single memory word. This is also another major contributing factor as to why Risc is so popular today when it comes to fast processors. It just pops out of my mind when I think about what's an easy processor, what's a fast processor, and Risc just goes there. Risc instructions are set like this size, and each one handles only one type of word, which means one set of instructions. So not many, and simple to understand. Instructions which include arithmetic and logic operation information on them must have the operands detailed by the instruction itself or in a processor register. So the instruction will have to include details of logic and arithmetic operations, which could be plus, minus, multiply, or divide or division processes. So on the instruction itself, or it could be in a register. So it's optional. All operands exist within memory before a program is first initiated. So before a program is first initiated, these operands do not exist within the registers themselves. They're in memory. So it takes some time to pull it from memory during its first cycle, but afterwards it gets quicker because it gets put into registers, which is a type of, you could use it as an analogy to RAM in the computer. It's like a cache, so to speak, because it's closer to the other components, so it's quicker. The load instruction transfers the operand located in memory to the processor's register, while the store instruction moves the operand from the register back to memory. This is very self-explanatory. So the load instruction essentially tells the system to tells the processor to transfer the operand from memory to its register, while store instruction just tells it to move from register back to memory. Risc architecture calls instructions and their locations through several addressing modes: immediate, register, absolute, register indirect, and index. I won't waste time. I move on to Risc pipelining. And this is you could say it's a quintessential point of Risc. Risc architecture doubles its execution speed by processing instruction fetch, instruction execute, and memory store instructions simultaneously. So it doesn't want to do all these things by cycle. If you have to do it by cycle, it's going to take forever. So you might as well have it do at the same time. So for example, in its you can see in its second stage there, IE and IF, instruction execute, instruction fetch cycles are run simultaneously. So this doubles the speed. It's simple logic. Instruction fetching essentially works the same for load, add, and store instructions, which is simply taking information from a register or memory. Very self-explanatory. And instruction execution works differently for add and load or store instructions, since the add instruction utilizes the ALU. So IE doesn't work the same for are not all the same. All the IE you can see in this pipelining are not the same, because some's for the ALU and some are just for the load, the general add and load or store instructions. Memory storing is exclusively for load or store instructions, since they revolve around register to register or memory. Stalls during the second instructions memory stage. This pipelining process stalls during the second instructions memory stage, since it uses single port memory, which is only accessing memory once at a time. There is a more efficient method of Risc pipelining, but it's not included in this report. But this model here was just to demonstrate a basic view of what Risc pipelining looks like, which essentially means putting all these instruction sets running simultaneously, which basically means running at the same time. So if they run simultaneously, you can double its execution speed. If possible, if you could run 3 times, but it is not possible. But if you could run 3 times, that means essentially 3 bars, like the 3 blocks, then you could run 3 times as fast. But here it's only 2. So that's all I think I have to explain for yes, that's all. Thank you for listening.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fauzan bin MAZLAM and my metric number is 074988. Today I will explain about managing performance for reduced instruction set computer RISC. There are several factors that contribute to the performance of RISC processor. Firstly, RISC processor have a small, simple instruction set that can be executed quickly, allowing the processor to fetch and execute instructions at a high rate, improving performance. Secondly, RISC processor use a pipeline architecture in which instructions are fetched and executed in parallel, allowing the processor to execute multiple instructions at the same time, improving performance. Thirdly, RISC use a register architecture, which means that all data processing is performed using register rather than memory, allowing the processor to access data faster and reduce the number of memory access. Last but not least, RLC processor use load or store architecture, in which instructions that operate on data in memory are separate from instructions that operate on data in register. That's all for me.
Good morning, madam and my fellow friends. I'm Bong. Today, I would like to present about the advantage of reduced instruction set architecture. The first of advantage is the Risc is designed to reduce the execution time by simplifying the instruction set components because it has simple addressing modes and a less complicated set of instructions, which make in designing a processor in easier and cheaper and quick. Next, the Risc use less hardware component and instruction sets, and each instruction only require one clock cycle to run. The time of execution is more efficient with decrease of the quantity in instruction and does not need to access the memory for each instruction. Because it did not need to access the memory, so it skips a process to execute the program. The Risc is simple to pipeline since they have a fixed size and their OP codes and operand are located at the same position in work. It is simple and faster the process of storing and prioritize the computer instruction that execute in a processor. The next is I would like to talk about the disadvantage of reduced instruction set architecture. The Risc, the first is it will behave differently depending on the code execute and take time to execute the first before it proceeds with the next command in their processing cycle. It requires more complex hardware and large memory cache as well as require extremely fast memory system to perform instruction in a short time frame. Because of the Risc is machine instructions are hardwired in, it will increase the cost to build and modify when the problem arises. It also will bottleneck when processing complex instruction and addressing mode. That's why the Risc is not suitable to execute high-level program due to its simple instruction. Okay, thank you.
Hello and good day everyone. I'm AMIZHDHAN here. We'll be presenting about the conclusion part of our project. So before I sum up the project, what is this architecture is? This architecture is a reduced instruction set of a computer in a design to simplify individual instruction to the computers to accomplish the task. So basically this architecture is a boon of modern technology that provides many embedded systems with the capacity to perform simpler and smaller instructions as physically fast as possible. More than that, this architecture is purely situational and is not suitable for all types of systems that are developed for consumer use in today's global market actually. So the concept of Risc architecture has undoubtedly led to a different, thoughtful yet simplistic design of microprocessor and design consideration on how much work can be done by the microchip itself. So Risc architecture has become a mainstay of the microprocessor production industries and is dominating the global market today, if in your information. So that's all to sum up about our project, and thank you everyone.